Now, when we're comparing different organisms or undertaking comparative anatomy, it can be really interesting to look at really very, very different animals, but see how they're actually very similar. And because of these similarities, this actually provides a great deal of evidence for evolution. And so, because we can look at different structures in different animals, we can see that they are very much the same. And when a structure in animals is basically considered to be the same, this is called a homologous structure. So, homology can be seen here in the, or for us, the arms, for the dogs, the arms or the legs, for birds, the wings, or for whales, the flippers. So we can see that we've both got an ulna and a radius here. We've also, we've got carpals, of course, our wrist bones. Dogs have got the same bones, ulna radius, carpals. Birds have wings. They're not arms, but they've got the same bones again, ulna radius, carpals. And whales have flippers. But again, they do have an ulna and a radius and these carpal bones in their wrist. So this homology, this similarity, does in fact provide a great deal of evidence that all of these organisms had a common ancestor back in the past that also would have had an ulnar radius and some carpals in it. But it's diverged, so they look a little bit different now, but they are very, very similar. We can also see this when we do comparative embryology. So this is looking at the different embryos of different organisms. So here I've got 8 different pictures of embryos. So if we have a look at these 8 pictures of an embryo, so not long after the sperm has fertilized the egg, these organisms have started to grow, and so we've got a little drawing of them here. These are crazy similar in the way that they look. And you're not going to believe it when I show you, but so this one here, this is a human. We've got a rabbit, a cow, a pig, a chicken, a tortoise, a salamander, and a fish. Very different organisms once they're fully developed, but they all start with this same basic body plan. So very homologous, very similar. So this comparative embryology enables us to see that lots of organisms start off the very same way. And this again points to this another example of evidence of evolution, that there was this common ancestor a long time ago, and it would have had a very similar looking embryo, which developed into whatever it was back then. Of course, once development continues, we end up with things looking very different. So fish look very different to humans. But as we go through the process, it's only that the differences happen kind of as they go. Now, another great thing to find when we're looking or doing comparative anatomy is something called a vestigial structure. So this is basically something, a component or structure of an organism which it's not useful anymore, but it's a leftover from an evolutionary past. And the one I really love is whales. So if you've ever seen a whale skeleton in a museum or something, you can have a look down at the back. They've got some bones which are just kind of dangling there. These are actually vestigial, so leftover, not useful anymore, but they are the leftover bones from legs or hind legs. Whales don't need legs, but those bones are still there because whales have evolved from an organism that used to have, hind limbs. So it's really interesting to see, and it's a really important piece of evidence which just proves that evolution has happened over the billions of years of life on Earth and is still happening today, really. So if we look at the homology of different organisms and also the vestigial structures, or the kind of useless, don't have any use anymore structures of organisms, we can track evolution as it has happened. And this is a really exciting and interesting use of comparative anatomy.